Hello, this video is on solving trig equations. And this is honestly just like the beginning of it. Mr. Schroeder assured us that this would be talked about more in depth when you guys get to calculus, either with him or Mrs. Dizer next year. But I just wanted to expose you to a trig equation. It's honestly very similar to things that we've done. So we're going to start kind of easy and then maybe get a little bit more challenging where some factoring will be involved. So your first example here, A, says that sine theta equals negative a half. And this is honestly, we're just solving to figure out what is theta. And we're allowed to use any solution between 0 and 2 pi. So you're supposed to find multiple solutions, not just principal values, any solution that would work between 0 and 2 pi. So we've talked about for quite some time that sine is the y coordinate. So you're going to want to pull out your unit circle. There is one posted in our calendar, or if you have one available. Just remember, sine is the y coordinate. So anywhere that the y coordinate is negative 1/2 would be your solution. So in this particular problem, you could say it's 7 pi over 6 or 11 pi over 6. Both of them have a y coordinate of negative 1/2. So both of those would work. For problem B, it says, where is cosine theta equal to 1? So again, we've talked for a while now that cosine is the x coordinate. So you're going to go around your unit circle and figure out where is my x coordinate 1. And it only happens one time, and that's at 0. You could say 360 or 0 or 2 pi, but they're all referring to the same location. So that is that. C, so we have to remember this one says tangent theta equals negative 1. So of course we can't just look at a unit circle and see tangent. We have to remember that tangent is sine divided by cosine. So this question is technically asking me where, when I do sine divided by cosine, or the y coordinate divided by the x coordinate, where will that equal negative 1? And many of you guys have seen this, that anytime you go to a degree that has anything to do with 45 degrees, or the denominator is always out of 4, when you divide the x and the y coordinate, you always get 1 or negative 1. Many of you guys saw that right away. We know we're dividing to get a negative. So that means either the y coordinate is negative or the x coordinate is negative. So you know you're either in quadrant 2 or quadrant 4. So you would be looking for values there. So that's why 3 pi over 4 works. Because when you do square root 2 divided by 2, divided by negative square root 2 divided by 2, everything cancels out and you're left with that negative. Same thing down here at 7 pi over 4, negative square root 2 divided by 2, divided by square root 2 divided by 2, everything will cancel out except for that negative. So just remember that with tangent, that you're always looking for sine divided by cosine. All right, next one says cosine theta equals negative 1 over square root 2. But of course, that's not on our unit circle. You don't see a negative 1 over square root 2. So first things first is rationalize the denominator. So to get rid of that square root in the denominator, we multiply the top and the bottom by the square root of 2. When we do that, we're left with cosine theta equals negative square root 2 all over 2, which of course is on our unit circle. You see a lot of different square root 2's over 2's. But cosine, of course, is referring to the x coordinate. So the x coordinate is negative over here in quadrant 2 and 3. So if you look, here's our negative square root 2 over 2 is our x coordinate. So that happens at 3 pi over 4. And it also happens down here at 5 pi over 4. Our x coordinate is also negative square root 2 over 2. So it happens in both places. So again, if you see a square root in the denominator, go ahead and rationalize it and see if you can get something that is on your unit circle. Sorry, I'm going kind of fast. I'm trying to do this in under 15 minutes. I don't have to make 2 videos. But go ahead and pause this whenever you need to kind of like regroup your thinking. So cosine theta equals 0.5. Of course, 0.5 is not on our unit circle. However, 1/2 is. And we all know that 0.5 is the same thing as a half. So you would be looking, when is my x coordinate, because that's cosine, when is my x coordinate 1/2? And that happens at pi over 3. It also happens down here at 5 pi over 3. So at pi over 3 and 5 pi over 3, our cosine, or x coordinate, is 1/2. All right, on f, there is, I do want you to change something. I want you to make f cosine squared theta equals 1/4. So to evaluate these things, though, it either has to be, you can't have squares, and like, you have to have the cosine by itself or sine by itself. It's almost like x. It's our variable. It needs to be all by itself before you can evaluate it. So to get rid of that square, I'm going to take the square root. So I'm going to be doing the square root of 1/4. But remember, when you take the square root of something, you have a positive and a negative version of that. So of course, then the square root of 1/4, square root of 1 is just 1, square root of 4 is 2. So cosine theta equals plus or minus half. So we're going to look at all the angles that have the x coordinate, cosine, as a positive 1/2, and all the x coordinates that have negative 1/2. So if you look, we have pi over 3, we have 2 pi over 3, you have negative 1/2, and a positive 1/2. Because remember, it could either be positive 1/2 or negative 1/2. That's why there's 4 correct answers to that one. So again, in order to evaluate these things, you have to have the cosine or whatever that trig function is all by itself, just like you would x in a linear equation or quadratic equation, whatever it is. All right, G, so same thing. My first move would be to solve to get the sine by itself. So just like you were solving an equation, you're going to subtract 1 first. When you do that, subtract 1, put it on the other side, you're left with 2 sine theta equals negative 1. But again, I want sine by itself. That's like 2 times sine theta. So I'm going to divide both sides by 2. So now I have sine theta equals negative 1/2. Of course, we know sine is the y coordinate. So we're going to look on our unit circle and try to figure out where is our y coordinate negative 1/2, which is going to have to be down here in quadrant 3 and 4 where y values are negative. So your two solutions are 7 pi over 6 or 11 pi over 6. In both cases, your y coordinate or sine value there is negative 1/2. All right, next one. Tangent squared theta, and I want this to be minus 3. Another typo. Woohoo! Tangent squared theta minus 3. Again, you're going to want to get the tangent all by itself. So first step, add 3 to the other side. When you do that, you end up with tangent squared theta equals 3. I have to get rid of the square, so I take the square root. And we have to remember, when we take the square root, we get a positive and a negative answer. So we have tangent theta equals plus or minus square root 3. Next thing we have to think about is tangent's not on our unit circle. To find tangent, we have to do sine divided by cosine. So really we're thinking about, when I take my sine or my y coordinate and divide it by my cosine, my x coordinate, I need things to cancel out where I'm just left with the square root of 3. And this one is a little bit harder to see. You maybe would have to kind of check, like, which version do you need. You're obviously going to not use something like with the pi over 4, the 45 degrees, because there isn't even a square root 3 in there. But you have all these other cases where there is 2's and 3's and things might cancel. So remember, we're doing sine divided by cosine. So y divided by x. So when I do this, I'd have square root 3 divided by 2, and I'd want to divide by 1/2, which is the same as multiplying, what the heck? Multiplying by the reciprocal. So that's why these 2's cancel, and you're left with just square root 3. So anything where square root 3 over 2 is the y coordinate, I don't know what is happening with that, and 1/2 is your x coordinate, would work. So that happens in a few places. It's like trying to make that text. I'm not really sure what's happening. So it works at pi over 3. We'll just pretend those aren't there, because when I divide those two, I would get square root 3. It works at 2 pi over 3, because remember that would make the negative square root 3. It would work down here at 4 pi over 3 and 5 pi over 3. And I show you where I was testing to see which one do I need. Do I need like the pi over 6 stuff? But when I divide those, my square root 3 is on bottom. So that's why I needed anything that dealt with 30 degrees. So that's both variations down there. And again, feel free to pause this if you need to kind of like look at that a little further. All right, the last two are probably more of the complicated ones, I guess you could say. Or no, I think we have 4 more. Woo! Okay. Same thing on this. You're going to want to add 1 and then divide by 2. And then, of course, take the square root to get the sign all by itself. And like we talked, you're going to want to rationalize that denominator. When you do that, you will multiply the top and bottom by square root of 2, and you end up getting that we're trying to evaluate when is sine theta equal to the plus or minus square root 2 over 2. Of course, whenever you see that square root 2 over 2, you know you're talking about your 45-degree angles. So look at anything with a denominator of 4. Where's my y coordinate square root 2 over 2? So that happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, because we also wanted the negative versions of that since we took the square root. So that is the answer to I. J, cosecant squared. So again, you're going to want to get the cosecant all by itself. So you're going to add 4 first and then take the square root. So of course the square root of 4 is plus or minus 2. But we can't find cosecant necessarily on our unit circle, so we have to think, okay, cosecant and sine are inverses. So I can find sine on my unit circle. So if I flip 2 over, 2 becomes a half. So when sine is a half, that's the same as cosecant being 2, since those are inverses. So then if you go around and find when is sine when is sine a half, you see it's a half at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So that one's understanding inverses and that cosecant and sine go together. All right, last two. You're going to have to factor for these. So sine squared x plus sine x equals 0. I can factor out a sine. When I factor a sine out, I'm left with sine x plus 1. Think about if you multiplied that back in, you'd get what you started with. So you just have to evaluate both of these. So your first one would be, I'm going to set sine x equal to 0, and then I'll set sine x plus 1 equal to 0. So you're going to look at your unit circle and figure out when is sine, my y coordinate, 0. And that happens at 0 and pi. You can see it here. So at 0 and pi, sine is 0. For your other factor, you're going to have to, again, like we talked about, solve and get the sine by itself. So you're going to have to subtract 1. So when is sine of x negative 1? Or when is the y coordinate negative 1? And that happens down here at 3 pi over 2. So sometimes you have to factor, and you just set all of your factors equal to 0. All right, last one. This is definitely the most complicated. So you're going to have to think basically what multiplies to get, this is like factoring a quadratic. So where you multiply a times c and you'd get negative 4. So it multiplies to get negative 4 and adds to get 3. And it's going to be 4 and 1. So we can rewrite this entire thing. Remember, we write the first term the same. So 2 sine squared x. I could rewrite 3 sine x as with my 2 factors. So 4 sine x minus 1 sine x. And then I still am going to write minus 2 and set it equal to 0. Then remember, we factor out our greatest common factor, which is 2 sine x. When I factor out 2 sine x, I'm left with sine x plus 2. between these two, they don't really have anything in common but a -1. So I can factor out a -1.